This question is tram. Linear kingdom has exactly one tram line. It has n stops numbered from 1 to n in the order of tram's movements. At the ith stop AI, passengers exit the tram while BI passengers enter it. The tram is empty before it arrives at the first stop. Also, when the tram arrives at the last stop, all passengers exit so that it becomes empty. Your task is to calculate the tram's minimum capacity such that the number of people inside the tram at any time never exceeds this capacity. Note that each stop or okay. Input at the then inlines each contains two integers AI and BI. The number of passengers exit the tram at the AI stop at the ith stop and the number of passengers at the stop. Okay. The stops are given last stop in order, the first to last. Okay. So this is the number of stations, and at the first station, at the first station, zero. Like at the first station, the um, at the first station. Okay. Zero passengers have exited the tram because it was empty, and three passengers entered. Then two passengers exited, and then five passengers entered. Then four passengers exited, and two passengers entered. And at the last station, four passengers exited, and zero passengers entered. Okay, so output is 6. Like we have to print the single denoting the minimum possible capacity of the tram. We have to get the like capacity of the tram. So what we can do is um, 3 8 10 10 okay. We will like okay, let's hashtag include bits using namespace std integer name. Okay. For integer cap equal to 0, integer I equal to 0, I less than n, I plus plus. And we will mm, okay, we will create an array integer passenger of n. Okay. mm, and passenger of I. We will we will iterate through like each time, here we can see that at first we will mm, uh, like count, like the first step we will minus it, count um, equal to count minus like the first zero, and at the second step we will plus it, and in the third step we will minus it, and in the fourth step we will add to the count, and we have to get the maximum, like we will for each iteration we will get the maximum of this number. Like at the first step the count is 0, then 3, and then 2 is minus, then so at first the maximum. Okay, let me copy it. At first our I have initialized a count equal to 0 at first. Okay, so at the first step I have minus 0, so 0 minus 0 0, and in the second step I have add 3 to it, so my count is 3, and at first, and my maximum will be 3. At the next step my count is 1, so because I have 2 minus it, so 1, and I will get that what is the maximum, 3 or 1? The 3 is maximum. Like at each iteration I will get the maximum of the count 3 and 1. At the next iteration I will have 6, and now my max is 6, and at the next iteration my count is 2, 6 2, and my my max is 6, because I have a count here, I have 6, like what is the maximum count I have till now. It is the 6, and so maximum will be 6. mm, then it will be 4, but my maximum will still be the same, and it will be the 0, and last it will be the 0, so my answer will be 6. So it is the output. So I have to do this for integer I equal to 0, I less than n, I plus plus. If like at, we can see that at 0 index, 2 index, 4 index I have minus the I have subtracted the count. If I is odd, sorry, I is even, we will count minus equal to PSGR of I, else count plus equal to PSGR of I. Okay. Oh, I haven't initialized 0, sorry, cap cap. Now what we will do is at every step we will get the maximum. Now we have to do the maximum, so if cap is greater than maximum, maximum equal to cap, see out the maximum. Okay, it is giving me the right answer. 403252 40, and my output is 6.